Okay, so yeah, so it's finally time to do this feeder. I was gonna try to finish the well, we could also work on the PCB, but and I'm pretty much ready to order the PCB. I'm just kind of chickening out. But we're gonna do one axis hopper. And the most important, I think, part is looking at the auger assembly. So this out of darts Jupiter thing has two mechanisms in it that allow it to to um, to feed. One is just this auger thing, which is just this special geometry that goes over a. So wait, actually, I want to go back to motor. So he puts in the blower. Yeah. So wait, we need to see the underside of this thing. Okay, so I'm imagining that I'm going to do a very similar thing here. So let's just okay, so I guess, how do we want to do this? The first thing is we need, wait, if I just do a, let's see, if I just do a stepper width. And stepper height. Wait, we don't actually have a thing for that measurement. Let's see. Oh wait, it's this. But all we want to do is we want to measure from here to here. That's 48. So let's just go into our variable studio. I forgot, this is so annoying. Stepper height really isn't in here? 48? That's surprising. Wait. That's the only one. Okay, 48. Oh, right. I was saying there's two mechanisms. There's this one motor that, like, I'm honestly surprised. Like, I don't really understand how this vacuum thing works, but it allows you to place the gun higher than the actual bottom of the proton pack, the outlet of the proton pack, and it's able to suck them all the way up the tube. Really cool. But I think that for now, just so that I can get something to test out, we're just going to skip that. So let's just get started with the, yeah. Okay, so yeah, so we're going to do a no dimension thing. So where is, it's this, okay. Rename to hopper. Wait, that's not even it. I don't even know what that is. Okay. Okay, cool. So, let's just start over. Okay, so we're going to sketch again on the top. Wait, what? Wait, what the heck? I thought Yeah, why did normal take me to the wrong normal? Okay. So, let's see. Okay, this is going to be the bottom plate of this. There's actually going to be two parts here. So, wait, how many parts are there? There's going to be... Let's just do two parts. I'll just make this a round number. Let's just make it 100. Then here, let's draw a rectangle. So this is going to be stepper width plus 1, I guess. Okay. So then we want to circle as in here, and then now I'm curious what the distance from, oops. This is 20. See, that's not enough. So we need this dimension. Where is this dimension at? Oh, it's governed by this? I see. Okay. So this rectangle is construction. Oh, it's not gonna... Okay. So basically we're gonna... this is 43. So we're gonna extrude this. Let's just do it by 3 or something. And then actually though, with this 25 thing, so wait, let's just get another look at this. Okay, so yeah, they use this like coned set screw thing. So okay, the general thing is like we're going to draw another sketch on here. We're going to draw a circle here. It's like, okay, then this gets extruded by stepper height and probably and then that's okay. And then on here we sketch. We draw just wait. But yeah, we can just do this, right? So this is going to be 3, and then we want to add. Now we want to draw a sketch on here, and this is going to be a stepper hole, and then we also want like a little circle here that's, what was it, 15 stepper, yeah, this. Okay, and then this is stepper mounting hole, which is, you don't have that? Oh yeah. Okay, and then we just do a circular of this. This is 4. Is that right? I can't tell. Let's just do enter. And that's what's still. Okay. Right. So now we just need to take... remove up to next. Okay. So there's like that. And actually, we probably want to countersync these. I don't know. But so then the idea is that you have a little... Can we get a view of the actual... Okay, this is probably as good as we're going to get. So... Yeah, so actually, this thing is bigger than you think. And then I think that there's the hose stuff. I just want to see them attach the actual hopper onto it, attaching the container.
At this point, we are completely ready to speed.
Oops.
Has been set up and that I like the settings. And really that's just those two dials on the actual board itself. One, again, will give you the actual fan speed, so whether you're getting enough feed rate coming through your tube, and the second is the threshold in which the current...
I also love those swivel connectors. Those things are so cool.
Activates the circuit, the current detection. So we're going to take our container. In this example, I'm using this 1 gallon container. Again, when this is in there, it's a 450 rounds, including the hose. So that'll twist.
Does it go on the outside or the inside?
Into place there, and then it locks with 2 screws, one on either side. These do not need to be tied to place.
See, do you see that though? It's okay. So it goes on the outside. So then the hopper goes on the outside, or I mean the actual like container. And it's just a set. It's just okay. So then you need. So yeah, it's good to make a feature list. So this is quite tall though. Okay, so then what you need and then he actually has like a small rectangle that goes like this. And he just extrudes this out by like probably 25. It seems high. What is this? This is, that's fine. It's this. So let's make this, maybe 28. And then what we're going to do is we're going to do another, so let's just delete these 2 features because we don't really need them yet. So we're going to do a sketch on here. We're going to go normal, and we're going to do, and I think that this just goes up. Oh, I wish I could rotate it. Yeah, they don't have any CAD. Why would I think they have CAD? Dude, so much work goes into designing this thing. It's actually insane. Dude, dual wielding. Dude, these guys are so fucking. Oh man, I want that so bad. Maybe
First option is a pre-built unit, and you can get that with everything set up totally ready to fire. So it will come to you. All you will need to do is plug it into a compatible blaster, charge up the battery, plug in the LiPo alarm, and you activates the circuit, the current detection. So we're going to take our container. In this example, I'm using this 1 gallon container. Again, when this is in there, it's a 450 rounds, including the hose. So that'll twist into place there, and then it locks with 2 screws, one on either side. These do not need to be tightened very far. They are literally just stopping the unit from turning. So it's really just a few screws.
Oh wait, is it threaded?
Literally just stop with 2 screws, one on the hose. So that'll. When this is in there, it's a 450 rounds, including the hose. So that'll twist into place there, and then it locks with 2 screws, one on either side. These do not need to be tightened very far. They are literally just stopping the unit from turning. So it's really just a few screws. And there you are. And now we're locked in place. I can then go ahead and actually fill this guy up. Overexposed. And then of course you are going to need your lid. So after you've got that lid on there, then we can grab our battery, and you can test it with the battery on the outside of your blaster. We are.
Okay, well let's just get the shape down. So let's extrude this. We want it to be like 75, right? We want it to be real tall. And now the distance between here and here is what? Oops. How do I get the measurements? There we go. Min dist 22. So that obviously is no good, because we're going to need much more than that. So if we go to this sketch, if that's, what did it say, 22? We need 3 more. So let's make this 30. Okay, now if we select this, this is 24, which is just barely good enough. Okay, and now but actually no, this isn't going to be good enough, because what we're going to have is something that goes on top of this motor. So if we just go ahead and start to make our assembly file, we're going to insert, what is it? Stepper. This is an assembly, I believe. And we need hopper. Great. Okay, so now that's almost right, except for we need to add a mate. What is it? It's going to be on here and then let's hide this. it's going to be onto there. Let's turn this back on. And we just need to flip it. Wait, no. What? Oh wait, I think... Wait, what are we doing? Oh, I think that this is right. There you go. Perfect. And is that... Are those the holes? If we turn this off... Yeah. So that's great. So now we just need to design the thing that goes over this. So what we need... Okay, so we have... How much distance do we have? We have from here to here, we have 21 millimeters. So... So here's what I'm thinking as a most basic thing. So first off, let's see. I'm just going to do a new part just so that I can start to figure this out. So this is going to be the auger. And so it's going to be, it needs to turn smoothly around this, which has a diameter of 67. Yeah, that's so big. Alright, so whatever. We're going to make it 70, I guess. So that's the ID though. So we need to make it 76. So we're going to sketch on here. This is going to be 76. And then, but the thing is, yeah, so now we want to extrude this by, and it really doesn't have to go down. Can we get that? Oh, there we go. That's side view.
Next, we're going to put on our auger.
Okay, so see, that one does look like it goes all the way to the ground. I mean, that's fine. I would love to see that from the underside. And then I'm just curious, so I'm going to do tangent, or plane, tangent plane, and why not put it there? Let's just sketch on. So we just want to cut out a hole here. Shift M. Okay. This, we want it to be, yeah, about 25. And similarly with this, 25. And we are just going to extrude this, remove maybe 10. Oh wait, we want to actually, or maybe that's fine. Do we want it to be a circle? For now, we just got to get some parts printed and start to see what to improve. Because it's always the first design that's so much harder than the rest. And then this thing is going to be turning this way, so this is where we could, and let's see, how big is that little notch?
auger, and the auger takes two 20mm screws those are two of the long ones. You're going to thread them in here and here. Before you do that, look down the center of this hole and make sure that it looks clear. You will see little metal bits. We have pre-installed the square nuts. Now, there's a chance that they might shift. We made this hole nice and tight so they stay down on the bottom, so they should, but just make sure that when you look through this hole, kind of hard to see, but you should be able to see a little light through that hole.
Oh yeah, I'm being a dumbass. For some reason I just did not, I don't know why they really need two there. I feel like that's kind of excessive. But yeah, we will need something like that. But instead of making it a cone, I might just make it like... But we could just try to recreate this. What's up?
Oh, I'm about to get in the shower right now.
Oh yeah, can I join?
Funny.
I'm finally tackling designing this the hopper, the thing that feeds the darts, and it's a doozy.
Yeah,
I sort of temporarily paused doing that 3D reconstruction thing because I couldn't figure it out yet. I switched to onshape for it, for like scripting the reconstruction, and onshape is way better than FreeCAD, but it's my code keeps giving this error, and I posted on the forum, and this guy that works at onshape gave me some code to fix it, and it doesn't fix it, so I replied. But every time you post on the community forum, someone has to approve it, so I'm sitting here waiting, and I'm like, I'm not going to wait around for this.
yeah. So what are you gonna do?
Well, I mean, it'll get approved, and he'll reply, and at that point, then I'll finish the code, but I don't want to just, like, wait around for it.
Yeah.
What about you? What's up? How's Debbie?
She's fine for the most part. She's just having like shooting pain.
Oh no.
In the area that they operated on, but yeah, nothing much. I went for a swim and I read my book.
No, out of the blue cramps and spasms.
No, I swam last night and I swam this morning and no cramps, luckily.
Nice.
Yeah. What are you doing for the rest of the day?
I am going to try to get some of these parts printed, and then I'm just going to go to class.
Oh, yeah. I forgot you had class today.
Yeah, I'm a student. I'm no longer a NEET. I'm no longer a NEET incel.
My favorite.
So yeah, luckily I found a product that this person makes like nerf blasters, like custom products that shoot nerf like the nerf rival rounds, the things that I have, and he has this super cool design for this hopper where it has two motors in it. One is this motor that has a propeller on it that like sucks the balls through the hose and feeds them to the actual shooter. And then a second motor that like agitates the container that stores like 500 rounds. And what's so cool about this vacuum thing is that then you can have the blaster like the hose goes up. Like the shooter itself is above the container, and it will still pull them all the way through the hose, which I think is crazy. So I'm not going to do that. I'm just going to say, okay, the the container has to be above the shooter.
Well, I can't wait to see everything. I am gonna take a shower right now. I'm like, I don't know.
Yeah.
I'm just standing here naked next to the shower.
Send a pic. No, I was just messing with you.
Yeah.
Yeah.
But I'll call you later.
All right. Cool.
Friends, call me later. I don't know.
Yeah. Well. See ya.
Whenever you're free. Okay. Bye.
Bye.
See you later.
All right. So yeah, let's just try to model this. I mean, the thing is, it does look like. Okay, it does look like the motor that he uses for this is smaller, so that's why this thing looks smaller. But effectively, the design is. Let's see, we're going to do this. So we need this to be. And then we could do something like this. So wait, so we only want this to be like. Five, right? This how big did we make this? 76, because we wanted a 70 here. Wait, let's. So we wanted to do so. S normal 70. Wait, is that right? That looks a little thick. Okay. So then we do this and we extrude this by 50, right? Wait, is it actually 50 or are we just clowning around? Okay, but let's just get it right. So then this and then this is going to be, well, let's see. How big do we make our gear hubs? So if we go to this probably has it. Oh, this doesn't have it. We need the bottom. Does this have the gear on it? No. Okay, bottom assembly. So, open, switch to. Okay, so, yeah, see, we have all these parameters stored in here. We never fixed that. Why isn't this, okay, there we go, 25. Yeah, we made it 25. We might as well make it 25. I mean, it's basically a gear. It just happens to have one thing on it. So, okay, wait, we're going to rename this to be hopper assembly. Okay, so now we have the auger. Okay, so we want to add the auger. Let's just add, wait, let's just do this. This, 25. Then we want to do this. Oh, wait, and this is going to be shaft hole. No, come on. Shaft. Oh, yeah, we don't have a... Dude. Stepper shaft hole. How hard is that? Is there really no 5.4? Stepper shaft hole. Stepper shaft plus stepper shaft clearance. All right. Okay. So this is going to be stepper hole. Okay. Now this gets extruded, remove, up to next. Okay. So, and then we do need to worry about these oh yeah, we have to worry about the countersunk fasteners. But okay, whatever. So now we want to go here and we want to extrude this by, so let's think about this. If this is sitting on the top of... Bro, why is it so slow? If this is sitting on the top of this... Dude, I feel like I'm gonna have to go through so many revisions of this, and it's like so over-engineered. Like, this is gonna take so long to print. I mean, look at this. 120 diameter, but whatever. Whatever. So wait, let's just add this thing in here. Yeah, so it's gonna be, if that's sitting on top of that, and this needs to be, so wait, from here to here is 21, then minus 3, so we need to make this 18. Okay, so the shaft should end right there. So let's add this to the assembly. Wait. Oh, wait. So it's like this, but actually what we want is... Oh, but actually what we want is... We'll need to fix that so that it's fastened. Is that just what they call it? Yeah. It's fastened to... Okay, so let's just change this. So instead of these, it needs to be to the stepper. Wait. Is this the part? Okay. So it's this. Wait. What the hell? Yeah, it's this. And it's the stepper. So let's hide this. Is that gonna work? Oh, that's okay. So we need, wait, we could just do this minus 18. So we're gonna do this and this. And we need an offset of Z18. Is that right? And this part we need to fix. Okay, and then this should be revolute, right? Yeah, we can have room for the cables, actually. Yeah, we'll have room. But I guess we do need to make like kind of a notch or something. I don't know how I'm going to do that. What the heck was that? Okay, so now this doesn't seem quite right. Can we get a cross section? P. Wait, why can't I get the P's? Or section planes? Can I just select this? Oh, fuck. I'm absolutely soaked. Lost my ice. I lost my LaCroix. Alright, it's fine. So yeah, actually, what is the distance between this face? Oh shit. Wait. What's the difference between this face and this face? Because what we could do on the auger is just add we could just make this what 5.4 plus 6, and we could just extrude this by, do we have like a socket head depth? Is that what we mean, depth? So what are they? I think they're, so this will mess with our mate. Is it weird that I feel guilty about wasting this ice? Okay. So, I think, wait, why didn't it do it? Socket head depth. Okay, so then this is now the mate. So we need to now adjust this. Wait, but it hasn't updated yet. Oh yeah, I forgot about this. Wait, what do you do? What do? You have to update. I forgot. But I remember, yeah, I remember that it doesn't automatically update. Onshape update part and assembly. The blue-white update. Wait, is there just an update? Alt-C update? It's grayed out, but it's like... Create a new version? Is that what I'm supposed to do? Yeah, I don't know how we get that in here. Do I just have to replace... No, what? That did not even update it. What the hell? I honestly don't understand how you're supposed to do this without doing it again. But so we want the mate to be here now. And we don't actually... And we want to hit it on... Let's see, I guess it's actually going to be on here. But we want it to be... I think that distance is... Okay, so let's do this. But I'm almost positive that this is 21. Let's see. No, that looks like some of it. Oh, maybe it's 23. 22. Let me just check. So if we hide this part, the distance between here and here is 22. Okay, perfect. So we don't actually have to make it that tall. We just need to put the, I don't understand though why it doesn't. Whatever. Okay, so let's just do this part. So wait, can we also look at the cross section? So this is not touching the ground, which honestly is like completely fine, I think. How do we get that section view to be, how do we modify the section view? Oh wait, oh you do. Wait, what? Oh, okay, yeah. So this is where that gap is. So that's probably where we want to be. So these cables will come down. This is screwed in here like that. We probably want to give it a little bit more room here. But then that means we want to parameterize that offset for sure. And then we're going to need this. We could just make this less high. But I just want to get something done. So this, not that, this. Let's make this, yeah, we'll have to do a second pass here. But if I do this, then I switch to here, it's not, oh, it is updated, isn't it? I don't know why that little feature there didn't get updated. But so I want to actually, it's so annoying how you have to do this every time. But let's just do it. So you sketch here. You make a line. It's a construction line. Yeah, we'll make it 5. We'll do, should we do M5? The height of this is what? It's 14. Oh, I wish I could just know. So this one was 25 and... Oh, this is also 14. So this is like... Oh, I wish I could just copy all of that geometry, but I can't. But that's okay. Or I probably can. I don't know. So it's okay. We're just going to draw a rectangle like this. This is going to be the M5. This is going to be the depth, right? And then we want the flats distance here. So this is going to be M5 flats. Then this and this, oh wait. This and this are going to be shift-emmed. Okay, so that's great. And now all we need to do is we need to extrude this down by the whack, right? I'm pretty sure we need to extrude this down by the whack. Oops. Is that right? Maybe that's not right. No, it is right. It is right. But let's look at this. So if we do this to here, that's 9.3. So can we just go to that feature? Boo, boo, boo. Okay, so we want this. This went down by 7. How did we calculate that 7, though? It's kind of weird. Okay, whatever. I'll do 7 as well. I'm pretty sure that's like the midpoint or something. So you take this, and this is 7. Okay, now we want to do the whole. Or now we want to do the... Wait, do you do the whole or then the... Oh, 7 is the hub depth over 2? Oh, yeah, there you go. I hate that we made all these variables in the... I feel like maybe I did copy them over. Let's see if... Well, I don't really care. This is the first draft. But so, yeah, so we did this. Then you do the circle, the hole, and then you do the... and then you mirror. Okay. Great. So we're going to sketch on here. We're going to draw a circle. That's going to be an M5 hole, right? M5 hole. We don't have an M5 hole. What the hell? Dude, that's the thing, is it's so wild. So this is 5.4. That's our M. Okay, then we take this and you right click and you do select other. Then you extrude this, remove symmetric, not second end position. So which way is which? How do we see? This one we're going to make 5. Okay, nice. And this one we can make, yeah, 25. Or we can make it... Perfect. Okay, now that we have that, we want to make another sketch on here. Wait, did we do it? Okay. And we... Wait, I don't know if I have this right. We're going to do this sketch. And now we want to take, there's a secret point in here. What do you do this? How the heck do you get this? Wait, I am sketching on the right plane. I feel like I did this in the wrong order. How the heck do you select that? So I want to look at this sketch. Oh wait, we just got to hit that concentric. Okay, wait, so let's do polygon, circumscribe polygon. There we go. Now we want to do this. Oh shit. Okay. And we want to do this. And we want to hit that corner. And we want to do a Shift M. And we want to take this and, oops, not that face, but not that face. But select other face of wait, is it that? It's not that. Maybe it is that. And then you extrude it with a remove up to face, and then you select this face. Did that work? Okay, cool. I think that's it. So now we just need to do our mirror. Oops, not a sketch, but a mirror. And we want to mirror entities to mirror is a feature mirror. It's this extrusion, this extrusion, this extrusion, and this extrusion, I believe. Is that one right? What is this one? Maybe not that one. And the mirror plane is going to be this. All right, cool. So yeah, so that should have been updated here, right? Yeah, cool. All right. So the issue here is that if we take this face and we take this face, our distance, min distance is 19, which is like way too small. They won't fit in there. So we're gonna go back to Hopper here, and so let's just make this 35. Okay, now if we go to the Hopper assembly and we look at this to this, our min dist is 24, which is pretty good. So now our stepper motor will, and then we need to, when in the auger, now we're going to make a tangent plane. I don't think we did a tangent plane here, so we're going to do plane, tangent plane. Or actually, do we even want that? No, I think what we want to do is we want to sketch on the front here. And we want to, do we get this line? We want to draw, let's just draw some lines. So let's do this U. Do we get that? I forgot how we get this. This is the weird thing about U's, is you don't get this. Oh, but you know what you do get? You take this, and then you just draw the line yourself. Okay, so now what we want is just like just say it goes out like 20. All right, but all of these. Oh, wait, do we do a tiny revolve? Is that how you do it? Or do I just extrude it? But of course, see, that's like so dumb. I mean, what we could do is we could just take, we turn off. Oh yeah, wait, hold on. first off, let's do this. So this needs to be nerf diameter plus 1.5. That's what he said. Oh. Wait, what? And this. We'll just say this is 3. And then what is still, oh, this. We'll say that this is 20. We need to fix this extrude to be an add. Yeah, but the problem is it doesn't, yeah. It's always so much harder working with curves than it is with, it's always so much harder working with curves. So, okay, wait, instead of doing this, can we try to do a very small revolve? So if the diameter is, what is the diameter here? 76. Okay, so let's revolve, shift, okay, so we're going to take this profile, shift W, revolve axis is going to be this, and then we don't want full, we want, symmetric, and revolve angle to be like 5. That seems perfect, right? And this is an add. So that seems good. How many do they have in the actual thing? They have probably 6.
20 millimeter on both.
Yeah. So now all we have to do is, and look at his. His are short and stubbier, and they have a better geometry. But I'm just trying to get a general thing that I can print out. And so this is definitely bigger. So wait, let's just okay, let's make this like 6. Let's actually delete this line. We're gonna go like this. We're gonna change this. I'm gonna delete this, and we're gonna say this and this are coincident. So this is going to be 3. Or let's make that 2. We'll probably have to print this with supports. So now what's wrong with this? Oh yeah, we don't have a distance on here. So I feel like 14 is actually pretty good. That looks a lot closer to what he has here. I don't like that it tapers out like that, but like, kind of hate that. Yeah, what I should have done actually instead, let's undo the revolve. Let's edit the sketch so that instead of this being coincident to this thing, wait, can we get the normal? Okay, how do we select other? Is it face edge? Let's delete this. And okay, wait, let's just delete the whole thing. All right, so we want like a line that goes like sort of behind this thing. And I don't know how we got an arc there, but so we're gonna go out to here, and it's gonna go up, and it's gonna go like this. And so here to here, let's just make it like 1, right? And then let's make not this, but the distance from here to here be 15. And then let's see what's wrong with this. That's that. So first we need this to, is it going to be that? It's actually not going to be that because this is raised up a little bit. So we need to figure that out. So this is wrong, but it's going to be, yeah, let's just say it's nerf. Let's just say it's nerf. Okay, and then this, yeah, let's just say it's 2. And let's say that this is 6. Okay, now we're good on that. Now what we want to do is we want to extrude it, and we want to do a symmetric extrusion of 2.5. So that looks way better. So let's just do that, and we're going to delete this, and then we're going to do a circular pattern of a feature, and we're going to select this extrusion, and the axis is going to be around this, and we want 6 of them. Wait. Wait, what? Wait, what the hell? Oh, I can't, I did the wrong one. Okay, it's, what is this? Yeah, it's that, and then the axis of pattern is around this, and we have 6 of them. Okay, but actually, wait, before we do that, we're going to roll this back, and we're going to take this, 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 and this, and we're going to fillet it. So they're a little bit stronger. And then we're going to go down here, and then we just, when we do this, we're also going to pattern the fillet. Awesome. So, okay, so then let's look at the assembly. So what I want to know is the height from this face to this face. 26. So that's a little bit more clearance than they had, but honestly, I kind of just want to print this. The only thing that's left, I feel like, that we haven't done is that small... Okay, well, wait, there's probably... First off, there's no features for actually mounting a thing in here. So maybe we want to add like we could add like a tapered cone shaped thing that we can screw in from the side. So we'll probably need holes around this. And then I guess the end of that big plastic thing was threaded, but I don't know about that. And then I'm not like entirely in love with this random cutout square. I feel like this is not going to work. I just want to, oh wait, did we already have this? What is this? I feel like that's nothing. So let's delete this. Let's look at this. Okay, and we're going to be going clockwise. So all we want to do is make a line out to like here. What's wrong with this? That's just constrained by this, which we could just make it 2. Let's make it 3. And then what else? This distance we can make, yeah, 24 sounds good. Because his didn't go all the way. And then we just extrude this to, we can't do 25, but we could do 20. We could do 15, though. That prevent them from going. And then, yeah, this is gangly looking. I don't really know how we want to do this. But I kind of want to just see if we can get any semblance of a hopper working. So we might as well just... Let's look at the whole assembly without the section view. And then the other problem is we don't really have a way of mounting this at all. The thing is, this part was the bottom part. The hopper is what I'm calling the hopper. Is connected to some larger stuff, but let's figure that out. I mean, we could just have some holes, right? We could just make some holes. So, like, so should we just do an, I mean, this thing isn't going to go under that much force, so let's just do M4s. Wait, at 4.2, that's too small, dude. I feel like we changed our clearance on that. I don't want to recompute a whole bunch of stuff, but that doesn't seem right. I'm just going to do 4.4. Anyways, let's make the distance from here to here. Yeah, let's just do 50. That seems good. And then we're going to extrude this, remove to next. And then we are just going to make, let's just do 4 of them. I feel like there's no need to go further than that. But this just gives us some future proofing in that, like, we could put it into some sort of base. I don't know what that's going to be. But so now let's just do a circular pattern of a feature. That feature is this extrusion, and this axis is going to be this, and 4 of them. That seems perfect. But actually, the problem with this is we don't have the... Well, honestly, I feel like all we'd have to do, like it won't change anything, is if we just made this like 7. And then we also M4 socket head OD. And then we just made this. So we did this. We roll back before this. We take this, oops. We look at this sketch, wait, not that sketch. This sketch, not this sketch. And we take this proof out, and we extrude it, remove, and this is going to be socket head, M4 socket head depth. That seems pretty good. And then all you have to do now is roll this forward, take this, features to pattern, also this extrusion. Great, and now it's now it's like attachable, and it's not going to interfere with the balls. The balls. And then maybe we should fillet this a little bit. I feel like that's probably a good idea. Maybe like a 10 mil fillet. Because then there's some gravity. My concern is that because see, the interesting thing for me was this part. Let's see. He once he presses it in.
Torque. I've got this set a little too low. Most of the way in, back it out and line it up to this all the way down. You should feel it snap, and there should be a pretty obvious you're at the base. You also can know that you have done it correct in that the ball should roll freely all the way around. And there should be a millimeter and a half above, approximately a millimeter and a half, if you want to get specific, above the actual thing.
I think it is domed, actually. I think it does look like a bowl. So we should probably do the same. Which means that... Oops. What does it look like? Yeah, so how do you do that? You need to... Let's go to the... So we did this. We did this. Because see, this is lipped up, actually. Oops. This is lipped up. This is no good. And I like this. Did he show one falling through it? I think he did.
And there should be a millimeter and a half above, approximately a millimeter and a half, if you want to get specific, above the actual thing.
See how it just rolls out?
Millimeter and a half, if you want to get specific, above the actual thing.
Damn, it's just like barely out of frame.
And if you want to get specific, above the actual thing.
Ugh. Okay, wait. Should we just change that feature? So wait, this might not even fit here. Now that I've made this thicker. How do we select this extrusion? Dude, onshape is actually sick. Right, so this actually... we need to delete this. Is this midpointed? It is. Wait, what happened here? I don't really know what's up with that. Okay. Dude, is anyone gonna ever approve my thing? Dude, I wrote a reply to this and they haven't approved it. It's so annoying. Okay.
You are good to go. On that note of lipo safety, make sure you are using a lipo alarm. Make sure you read all of the care instructions for lipo batteries, and please be careful with them and store them properly and take it as a hobby. You better learn how to do this. So again, we have two versions. Just keep that in mind going forward. This is the Proton Pack feeder. This is the core to everything there is to run this system. It can feed 20 rounds a second for forever, as long as you have the capacity of balls to hold as many as you would like. The base system includes a battery base and the body, along with the snorkel top, which we'll get to in a moment, the impeller, the blower. It will come with 7 of these clips and then optional adapters. Starting off with mounting your container, there are several ways to do a container. The first is that we are going to offer a 1-gallon container, which when you factor in the capacity of the hose, which is about 20 rounds, this holds 450, including the hose when mounted to the unit. The containers themselves are connected with interchangeable rings, and we've got a couple options. The first is a 1-gallon ring. This connects to that same 1-gallon 450 round container. Now you can order it the container from us pre-cut with this pre-glued on here. That's an option at checkout. You also can order just the ring by itself if you want to pick up your own container and save a little on shipping or whatever. Should you want to go with a larger container, we've created just a flat plate glue-on with a little bit of texture here to help actually keep the container easily glued onto your surface. And so what you want to do is just simply trace this into your desired container and then cut a hole and glue it. Very, very simple. These attach onto the feed unit just by a little twist lock, and then after you twist them in place, there are 2 set screws on the ends, which just simply stop it from rotating. They don't need to be over tightened, just pretty simple screw-on, lock-in-place connector. At the core of the whole system is this base hopper unit, and this is the feed system along with the blower housing and the outlet for your balls and your hose. On the base, we've used brass inserts, and on the top brass inserts, we think this is a nice polished look, and they're easy for you to deal with when you get them. So there's no need to install these. These will come pre-installed when you get your unit. Next, you've got your lid. The lid's got 2 options. You can use it as is, just like that, or you can choose to use the snorkel. Now, the snorkel is a 2-piece part that simply goes on top of here and will allow you to connect this to the same hose as the same type of hose as the actual feeder hose and allow you to get air in, assuming that you're putting this in an enclosed space like a backpack. This part is the impeller. This is the core to the entire system because this is what actually blows the air and pumps enough pressure into your system. We tested this extensively to get the maximum performance out of this design, and it can push quite a bit of air, enough to power the Proton Pack to push 4 feet of balls straight up vertically. Next, you've got the auger. The auger is what actually impels the balls and makes sure that they are feeding in correctly, and that's fairly simple. Cover that in a tutorial. There are hose clips included. These hose clips will keep the...
Actually, does it look domed? I can't tell if it actually looks domed or not. See that ridge?
These hose clips will keep the wire connected cleanly to your hose. That way they...
But like, okay. Let's see what I want to do. All right, let's make a new... I just want to make a totally new document, and I just want to toy around with some stuff. And this is just going to be like a helical hopper. So what I'm thinking here is... Okay, let's just start with... Wait. So you have this, which is 75 or something. And then you have this, which is like 130. Okay, and then what we want here is, first off, these get extruded by 3. Okay, and then, oh wait, do we get to continue extruding this? I guess we can. So this is from the base, and this is going to be So actually, wait. Um, is helix a create a helix or conical cylindrical face? Helix. Wait, so it's this. Okay. Okay, so I think I get it. We only need one turn. Wait, and it's not going to be end condition end point. Wait. We actually want this to be counterclockwise. Right? Because it's highest here. No. We want it to be clockwise. But we don't want it to be the whole turns start condition. How do I... So, right, so this is the end. So this is where we need to make the, that's going to be the outlet, right? So then from here, this goes around, becomes that. So there's going to be the little wall here. And then I don't know how to... Is there a way to partial helix this thing? Okay, well, let's just, how do we do this? We want to... I mean, like, if we take a... What's a standard thread? These aren't modeled, though, are they? Does it actually model it? I don't think it does.
Hello everybody and welcome back to the YouTube channel. And today we have a different kind of tutorial. We're not talking about cameras, we're talking about CAD. How do you actually solid model, 3D model threads for your STL files and your other objects you're going to create in CAD. We're in onshape today, and since you can't just use a call out when you're actually 3D printing, you need the physical 3D model threads. We're going to try to create those. So let's open up CAD and follow the intro. Okay, so here we are in onshape, and we're going to start out by creating a sketch on the top plane. We're going to use the circle tool, and I'm starting at the origin. This will become a little bit clearer later, but it makes things a little bit simpler when you're doing the actual 3D modeling of the threads. I'm making my cylinder.
Okay, so if you look at this, we basically want oh, cool. Wait, so now can I just go into here. Dude, someone freaking respond to me, bro. Okay, wait, so let's delete both of these. I don't even think that this is actually going to do what I want. Pitch, we want the pitch to be maybe 5 millimeters. And then we want number of starts, fully threaded, number of turns. We want it to go from the bottom, though. Number of turns, 2. Yeah, so wait, how can I... I like the start tape. So, okay, but this isn't the actual profile we want. Let me try to think about this. How do you... I mean, it has to be with Helix. I mean, Helix is clearly... All right, let's just try to... yeah, okay, that's fine. Let's Helix this. Okay, then we're going to do a sketch on here. We're just going to do... Let's see, don't we want to do it here? Okay, so this is, we're at this endpoint. So we want to do... Let's just make a... Okay, it doesn't really matter. So we're going to take this, and we're going to do a sweep of this profile. It's going to be an add, and the sweep path is going to be this whole thing. So see, this is kind of what we want, right? I don't know why it's transparent, actually. But maybe that's just because it's... Wait, is it transparent? No, it's not. Okay, wait, so let's try this. What we're going to do is here, instead of 25, we are going to make this 5, okay? And then this helix, we want to say the pitch. And how do I specify the pitch? Target pitch. The pitch is going to be 5. And let's see, we don't get a single thread here. This thing does not do anything for me. I don't know what that's about. Let's make the pitch 4. Yeah, see, we don't get anything. Oh wait, yeah we do. There it is. Okay. So yeah, why don't we make it 10? And then this should recompute, and now we have one full... Wait, no, we have... Wait, what? Let's make this helix 10 now. Okay, I feel like we get pretty much one full turn. It goes from... Yeah, there you go. Okay, wait, now we want this sketch. But what we actually want is, let's delete this. What? Okay, what we actually want is just a rectangle. It goes out to here. And we want this could be 2. And this could be, we want this to be 25, right? 30? I don't know. But so now if we take this sweep and I couldn't find this, we just select this. Right, okay, see now, we just want to make this a little bit taller. I don't really understand this pitch thing though, because it's like, well, what if we just make this 12? Something gonna go haywire? Does it tell me the angle? Since they're not on the same... It would be cool if it was able to tell me the angle, actually. So, this is probably better though, right? Like, now the question is though, you still need the flat base. What is the actual diameter of this? So this is 130, and this is, oops, 75. 65 minus 75, that's kind of an annoying number, right? 37.5. Oh, what the hell? 65 minus 37.5 is 27.5. So now we just need to, when we do this sketch, this needs to be 27.5. And how the hell is that? Oh, maybe it is. Can we use this? Yeah, so wait, let's delete this. And now we have it. Okay. Great. That's pretty cool. And then I wonder if we can just extrude this, add up to next, or up to face. Can we do this? This probably won't work because it's not. Oh wait, up to next. Is up to next that dynamic? See, that's the weird thing, is that like I want to fill in the stuff under it. How do you do that? Is this and this is going to be at an angle, right? I mean, not that it matters, but there's all sorts of little things that make this weird. But I feel like this has to be a better design, like, because now the balls. Well, the only thing though is that, dude, I really wonder if they do this. I wish they would release CAD files. Okay, it's clearly rounded here. And they probably just make it rounded. Gosh, I wish they showed me just a little bit better of a... Just slightly better what it actually looks like. Okay, but it does sort of look like there's like a tangency here. So instead of drawing on the center of the tangent plane, they oh wait, can we... Honestly, I'm like so tempted to just print out this thing and just see how it works. Dude, I mean, these parts are just terrible, though. Have you ever seen someone design such garbage? Fuck it, dude. Let's send it. I want to order the PCBs. But honestly, that breadboard stuff is pretty adequate. I wonder if they ever made my diode. I feel like they never got back to me on that. Okay, so it's just 2 parts. This part is a total mess, though. I'm gonna have to print this way down, and hopefully we can get it with no support. But like, that's actually impossible because of this spacer. Wait, what if could we do it from the? We could do it from the other side, right? We could do. Doesn't even need to be 3. It could be 2. Anyways, this just needs to be 4, right? Is that right? And then we could take whatever this feature and just delete it. Oops. What program was I using where I had to keep saving? I think it was in my class. Wait, hold on. Oh, wait, but I deleted the feature on the mate. Okay, wait, can we... Alright, so can I move this? Oh, wait, M. Just move this. Thank God. Okay, so what we want here is to join this to... Technically, we need to join it to here, but I'm just going to do it to here. And then let's just delete this. Great. Okay, now let's get our section view. Yeah, the slope I feel like would be really good, but and I'm kind of worried that these aren't going to really fit, to be honest. Why is this like so thick? Why is that 5? There's no reason for that to be 5. This whole thing can be way thinner. This is 7 just literally because the counter bore, but that's countersinking. And I guess you kind of need standoffs, or whatever you need needs a channel for the wires, but honestly, this is a first draft. Okay, so oh yeah, but wait, we still need to figure out, because this is 125 and this is 131. What we want to know is how we are going to add the container, and whether or not we even have an appropriately set, because I don't want to print a container. One, it won't be transparent, which is like not nearly as nice. But so let's just think about how this would work. If we take the distance from this face to this face, we get 15. So what I'm thinking is, we have a tangent plane on the hopper somewhere, right? So why don't we draw a sketch on here? Let's say we'll make it a M4 hole, And then what? Do we just want to put a hex nut on the other side, or do we want to... Because this isn't thick enough for a threaded insert. Threaded insert would be really nice. But do we want to... I don't really want to increase the... No, I'm fine with a nut on this. I don't really care. So we're going to take this... Wait, what's wrong with this? We need to make the distance from here to here be... Let's just say it's 7.5. That seems good. And then we're going to take this, extrude it. And then the annoying thing is that a remove up to next fails on curved surfaces, which I feel like it shouldn't. And I don't know why it does. But whatever, we're going to do a blind. And we'll just, I mean, that's fine. Well, let's make it like 10. So that it doesn't hit anything, just in case. Great. Actually, we should be able to make it just 5. Okay. Now we just want to circular pattern that. And let's just take this feature, axis of pattern, this, and then we'll put just 4 of them. And so then let's make a new part. We'll just design this just so that we can have an idea of what it looks like. On here, I think that they actually did a chamfer. Let's make it a 2 mil chamfer. Or wait, actually, can we make it a... What is the width of the thing? Three. Let's make it a 3. So, where was that chamfer? So we're going to take this chamfer 3. Do we even want that? I mean, it's nice, but like, do we even want that? Wait, how do I just go to my own? Yeah, okay. Okay. So let's just not do a chamfer. I don't really care about the chamfer. But what I do care about is we are going to need something that is slightly smaller than 125. But it does need to be kind of snug. All right, so let's make a new part. And we're going to call this hopper container. Okay, so sketch. This is going to be 124.5 probably. Is that enough clearance? That's like that's going to be minus 124.5. Is that what I said? Let's just make it. Let's make it 124. We are really playing fast and loose with this. I'll probably have to redesign everything, but so here, that's the ID, right? Or wait, that's the OD. So then here we want to just make this, and so this is going to be like 10, right? And then we're going to make a plane, tangent, select this, okay. Then we're going to make a sketch on here. I hate that. And then we're just going to make it, does it matter where we make it? This is going entirely into the thing, and then it's going to bulb back out. So wait, what am I doing? So in here on this sketch we made it, yes, so the top of that is going to match the top of this. And wait, what the hell? Where is the sketch? There it is. All right, so it's 7.5 down. Wait, so then we'll need to make that a little bit taller because the bottom of that, if we select this and we do max distance, it's 9.6. So we want to make it, we can just make it 15. Did that make anything bigger? No. Okay, cool. So we're going to take this, we're going to draw a circle here. It's going to be a M4 hole. And then on the interior of this is going to be a hex nut, but oh Jesus, dude, okay. Is there something that searches all of my parts used and stuff for the usage of this? That would be so useful. A feature script thing that just searches so that you, because this can't be, because we got to change this. 4.2 is too small. I'm going to do M4 hole 2. That's just the cringiest stuff ever, but I don't really care. So here, give me M4 hole 2. And same here. Okay. 7.5. Extrude. Remove. 5. Circle. Feature. Okay. So now what we want to do, though, is... Oh, do we actually have enough room here? So... So let's do just like a basic revolve. So we're going to sketch on here. And we're going to do like... Can I take both of these and do a U? Okay. So we're going to do a line. I just have it go out like this. Okay, and we are just going to do a revolve of this whole profile around this axis. What happens if we do it on the inner axis? It's the same thing, right? Okay, cool. Oops, not that. So now in our hopper assembly, we want to insert this hop container. Okay, and then we want this, so we're going to do a mate. Oh, bro, it's so... Why does everyone get this wrong? Wait, if I click on this, can I modify this point? Yeah, no, this is no good. How do I get it? Oh, wait, there it is. Okay, we want that. And we want... So it's the outside of that and the inside of this. Wait. Let's do it again. So you gotta come in here. There we go. And the inside of this. Is that right? Okay, now the question is, from here, wait, why is this from here to there? Min distance of 20. See, this is not gonna work. So we need to, this is why doing these first drafts sucks, because then you always have to do the real one after. What we could do, actually, though, what does that save us? That saves us 3 mils, which is enough, is if we design it where it's on the outside and it has a lip. What does that look like? That looks like it goes up like this. It has a little thing like this, so it sits down. I'm trying to figure that out. What? I mean, the thing about this is that then you don't need the lip because it just automatically sits in there, which is really nice. Honestly, we could print that. I mean, just to get a sense of it. All right, so let's just... Should we just start over? I feel like I have a pretty good sense. The only thing that I don't like still is this outlet. I really dislike. And then I don't like that there's no gravity pulling the balls actually to this outlet, which we have here. I just don't know, like... Oh, you know what we could do? No. I was thinking of just making the sketch profile really thick, but then it's going to go down too low. I mean, we could just do another cut where we just draw a big circle and cut everything, but let's try that. Let's try that. So we have this sweep, we want this sketch, and we want this. We're going to delete this. We're going to say that this point and this point are collinear. And we're going to do it again. Right, then we're going to draw a sketch on here. Or actually, we're just going to extrude this. It's a remove. It's this way. Selected tools and targets don't intersect. Oh wait, it's gonna. Okay, wait. Can we just? Okay, wait. Can we do this? Wait, we're gonna select this. We're gonna sketch on here. We're gonna draw a circle. Okay, now we're gonna take. I wonder if can I just hide this? Wait, let's do this. Can I hide this? You can't hide sweeps. It's kind of weird. There's got to be a way to take this whole... Okay, wait, we're selecting the whole thing. Can we just remove through all the other way? There we go. That's perfect. That's exactly how we want it. So maybe we'll do that. You do a helix with a big... pitch. The only issue is that now we need to make sure that the agitator is from this point. So the clearance here from from this has to be 25 above that. And what is the distance between here and here? Crap. Wait, no, wait. What is the distance between here and here? 9. Yeah, that kind of checks out. Should we try to do this tangential thing? I'm like right clicking to try to pan around this thing. It's so funny. Once you have CAD tools, you just want to use them. So I feel like that profile looks like a... The thing is, I don't really understand where the airflow goes, but I think that it's largely the airflow. How does the airflow thing work? Did they show that in there? Bro, can someone please respond to me? I really want to do this. Build guide. Oh, it's here.
The wire isn't flopping around and tangling. Next, we've got the battery base. This is in 2 parts. And so on the battery base, we pack the 100 milliamp engineered packer. So the base a motor. XT60 Chaos. Rewire your blaster to use this, and you don't have to change your blaster. You simply plug that XT60 connector in, blaster and power adapters, and we do is the same hose, and it's a 90 degree. Next, we have a double swivel, which is a 90 degree swivel that can swivel like this. And
dude, I love those swivels, man. I wanna make a swivel thing.
Turn this direction. The 90 degree with the extra swivel is included with the Perseus due to the orientation of the ball inlet on that blaster. So all of these one of these is included with each adapter, so keep that in mind, but you can buy these separately as well. Moving on to the adapters themselves, one of the more popular options is the Jupiter. This is the Jupiter adapter. It's got a nice swivel in the back. Again, these swivels clamp right under the hose. There's no put your screw back in there, and the XT mag wells for them printing what you want. My great set of parts due to the black objective, and that requires phenomenal. And you've got a nice swivel connection, your hose coming out of there, and you are basically good to go when it comes to the proton pack. For those going a little more DIY route, I did make a little bolt-on connector. This has got 4 screw holes and a simple twist that you could use as sort of a DIY method if you're going to bolt this onto some existing feed. Just gives you a good not available.
Dude, this guy is so sick, man. Does he show how the
is a PCB wiring? So into this is the core to everything there is to.
I don't really understand this vacuum part of this thing.
Run this system. It can feed 20 rounds a second for forever, as long as you have the capacity of balls to get right to it. We're going to start here by assembling the motors and getting them installed. So we're going to take our base plate and flip that upside down, and we're going to take our brushless motor here. We're going to unthread this. It's worth noting this is backwards threaded because it tightens on itself. There's one large hole down in here, which these wires need to thread through. It's the largest hole that's in here. It should be fairly obvious because once you shove it inside, it'll come out right there. And hopefully that's pretty understandable. There's nothing to do wrong here, so you're just getting that lined up. Then you're going to flip this back over and hold this with your finger. And you're going to take your 4 black screws and install them in the 4 holes there. Now, because this motor moves around a lot and has a tremendous amount of torque, we are going to recommend that you put thread locker on it. I'm already going to abandon using this little 2.5 mil. There's nothing wrong with doing this. I've just done enough of these and I don't want the video to take longer to film. I'm going to go ahead and use my actual driver tool. Another tip here is that we use these slipper clutch ones. So if you ever do get one of these, exactly where we want, because I'm going to start by putting them in here.
Aesthetically, this is also way nicer. Should I go the extra mile to try to freaking to try to do this? I mean, this I feel like I don't want to do that.
Vibrate themselves loose as you're using this. And there we have it. So that's the install of that. You can then pass these wires down through under this little wire channel. And that's just enough to keep that out of your way later. Just like that. And you can tuck those in for now, but we're going to flip back around. We're going to take our gear motor, and we're going to put that up through the center. Should be pretty obvious. It's got a little bit of play left to right due to how the design tapers on the actual motor. But once you get that in, you're good there. After you've got that motor inside, I recommend setting this on the base here so you're not scraping anything, but you will need to start at least one screw to get this going. Each of these should get a little bit of Loctite, so you can put a little thread locker on there. Loctite's a brand. You may hear me use them interchangeable, but it's all thread locker. We've got a couple options on the site. And then if you want to avoid damaging your tabs, it's kind of nice to just set this on the base there because that's what it's designed for.
Dude, I wish I could like turn up the brightness. You can't really tell what's going on.
So I'm gonna go ahead and get the other 6 motors put in.
Damn, they're 4K. Will that work if I try to zoom into it?
Once I've got them all in, I'm going to tighten them up, just make sure that they're good. You can hear my little clutch actually engaging there, making sure that I'm not putting too much torque on them. So after we've got those 2 installed, those motors are ready to go. The Loctite is not totally necessary here, but I'm going to think of that working itself loose as it's working and grinding and pushing through balls and whatnot. Next, we're going to install our blower. This is the actual blower fan, and you're going to want to line up these 2 tabs here on the inside with 2 notches. It doesn't matter which 2 notches. Here, a little circle. Line up basically that little gap right there or that little gap right there on both sides with the little tiny dots that are there. And it doesn't have to be quite perfect, but there is just a general alignment because then it'll seat and lock. And if you feel it kind of click at the end, you've done it right. And there's another indicator here that'll tell you you've done it right. I like to just hold the nut and spin this clockwise from this perspective. And then you're going to take your either 8mm wrench, or again, you could just grab on here with larger pliers to make that work as well. And you're going to tighten it further. And you can do this just by spinning the actual, holding this in place and spinning. You'll feel it get tighter. That's when you know you're good. The top of that shaft is just barely, maybe 1mm, going to break the surface of that nut. And that's when you know you've got that right. You can give that a few spins, and it should feel nice and smooth. I'm trying to keep the build order here fairly specific. And the reasoning for this is that if you don't do it in the right order, you'll end up fighting components more than you would like. So next, we're going to move on to the fan cover and the snorkel.
I just don't understand the airflow. I wish you'd explain that.
Now, the fan cover has 2 methods of operation. The first is you can simply pop this in and take 2 of your 10mm screws and screw them in, and you're done. This is great if you're going to have this external.
Have
a fair amount. They can take a fair amount of force, but don't go drilling on them with a power drill or something like that. They might cause you some issues there. Next, we're going to move on to soldering. So before we install this auger, we're actually going to flip this upside down and work. This shaft does go above the flat base here, so you're going to want to find maybe 2 pieces of wood or 2 pieces of anything that you can set this on. If you don't have that, you also can...
Okay, so I think the best solution here is to use this helical thing. We're going to start from scratch again, because now I feel like I got a rough draft. I mean, honestly, this seems good enough. The only thing is, okay, well, what's the height from here? To here. This is 27. So oh, and then the other thing is that we need to decrease this height. So okay, let me get a hand drawing of some of these dimensions. So the first thing is this bottom plate, which is just flat. And then we have another plate here. This, I don't know what this OD is. Because, and then this thing, we decided on 70, right, for this one? 67. Oh, no, yeah, 67. This is 67 due to the circumscribe the stepper corner so that it'll fit in there, and then there's just a little bit of clearance in there. Looks like there's a lot of clearance, but there actually isn't. Like if we were to rotate this section analysis by 45 degrees, you would see, I feel like that there's not that much clearance. Yeah, if we took this and this, there's 3 mils there. Maybe we could pull it in slightly, but I mean, honestly, that would be good. Pull it in slightly. So that's 67 from that. Then we have then we have this helix. So then the helix on the base of hopper. And that has a height of 10. So that means that's at least how much shorter. Oh, but that means we can still get these notches to be where we want them. We just have to shorten this part of it. The auger is to avoid collision interference. Oh, and then one thing that we're missing too is here, let's do you want to do that? Or no, we have to do it or actually nah, this is goofy as hell, man. Wait, you can't? Okay, I don't know. I'm not sure how you get that fillet. But what we actually want this is so dumb. That's 14. Oh yeah, that is 14, huh? Okay, wait, can we alright, can we delete this? I wanna export these and just see what the slicer says. Oh wait, actually, you know what we could do? That's a lot better. Alright, so that's cool. Oops. We want to export this as... I don't know what the best one is. I always just go step. So we're going to go to 3D, ball shooter, onshape. Wait, what? Okay, we have the auger. We have the hopper. Let's open up bamboo. And this time I'm gonna baby this this print just so that nothing weird happens. Um, 3D ball shooter onshape. Wait. Why the hell did I do that? I always do that. Let's see. Probably. Wow, that was a long slice. Okay, so let's just see what it does. For some reason, this so slow. Yeah, so those were to be expected. Yeah, that's insane. I feel like... What happens if we... It's going to complain to me, but I don't want... Wait, what if I do a... Ugh. Yeah, that's no good. We gotta figure out how to get rid of supports for that bottom. Sometimes a fillet will get rid of it. But if we just do like a 3mm fillet here, might interfere with the thing. But if we, dude, it's the most annoying thing though is about exporting. It just seems to take so long. I feel like it's still gonna complain though. What is his design here? Why does it take so long to load, bro? This is freaking 4K. There's no way I need this. I mean, his design is quite similar. See, before he puts it in. I guess there must be threaded inserts down there. Or no, you know what? The top of the motor probably has... Yeah, see, the top of the motor has the...
Enough to keep that out of your way later. Just like that. And you can tuck those in for now, but we're going to flip back around. We're going to take our gear motor, and we're going to put that up through the center. Should be pretty obvious. It's got a little bit of play left to right due to how the design tapers on the actual motor. But once you get that in, you're good there. After you've got that motor inside, I recommend setting this on the base here so you're not scraping anything, but you will need to start at least one screw to get this going.
Okay. Let's see here. What could we do? Well, okay. Bro, someone please respond to me. Okay. And then in there is lift it up. Okay. So the main problem is just getting rid of supports, I guess. Oh, same with this, dude. Yeah, what the heck? Oh, the amount of support. I mean, that's why this design is just so stupid. It's really gonna print a solid freaking block of this stuff. Look at this. It's gonna be... Look at all that green. Look at all that green, man. That's not the kind of green you want. That's the kind of green you would rather not have. I'm wondering if we could try to... Try to reslice it. I feel like this at least will have less support because it'll just be under there. The issue is going to be, it's going to be all in there, which is like the features that you kind of don't want it to be in. All right, well, maybe I should just start the redesign and we'll go from here. I mean, the thing is, I just don't know how you can avoid, because you have to build a cup that goes on top of it. I don't see how you can avoid... I I mean, what you could do is you could like sketch on here. What's going on? You could make 4 holes here or something. How do you do this? Okay, how do you go up? I'll just double click it. 4. Ah, crap. Whatever. But let's see. Yeah, so you put, okay, maybe I'll do that. So you put some threaded inserts here. So you just have the base that has the helix. You put 4 threaded inserts here. Then you put this cup. Which part am I thinking of? Yeah, you put this cup on the top of it. The only problem is that it makes it a little bit harder. Makes it just a bit harder to fit because then we maybe have to make it a little bit bigger. But, so what would this be? This would be like M4, hello? Oh shit, it's because we're in a new, yeah, we shouldn't have done this in here. We should have done it in here. It just gets so messy. Let's just rename this to be Hopper 2. So, first we need our base. I wish I could just copy everything here. Does that work actually? That'd be so cool. Nah, that's not gonna work. It's okay. Wait, do we have a sketch? Okay, so we want this to be, should we just do this for real? So, what are the driving dimensions of this thing? Well, okay, maybe we need to do a second first draft so that we test out a couple features that I want. So I think the first thing I want is to start separating this out into maybe 2 parts. Separating out this into 2 parts because let's see here. How are we going to fix it to the thing, though? Maybe it could go from under, actually. Maybe it could go from under. So what you would do there is you would, let's say that, what was it? It was like 70. So you'd make this like 70. And then, yeah, okay, so this would be, wait, but if this went all the way through, it would be no good. Or actually, no, that's about perfect. So it'd go like this, but then you would also, you'd make like a, I mean, it really doesn't, it shouldn't matter because we have 7 here. And then was this the part that, oh yeah, and then I guess the other thing that makes this complicated is that if we want to attach this to something, then the helix, then, yeah, then the problem is that the bolts you need are going to be different lengths. But maybe that's not so bad. It comes down to how much I think I'm going to need this gravity pulling down the balls into the chute. I do like the look of this, but I'm wondering how much that is just because it is more compact. I feel like that was probably why he made it like that. and not that it can't work going out perpendicular to the center. Okay, but then countersinking will be kind of annoying because you don't have a flat face on which to sketch. So if we go to this, let's go to this. How do you sketch on here? Does it even let you sketch on here? Wait, what did it say? Yeah, so you can't sketch on this helix. I guess what you would do is you would just do it here. So you would just, but then how do you do the countersink? Oh, this is the problem with angled stuff. It's like, you can't sketch on here. That is kind of frustrating. I mean, I understand why you can't sketch on it, but you know what we could do? I mean, it's like such a hack, but what we could do is just let's just what was this, right? We're gonna just make this 140. No. We're going to sketch on here. So first off, this wouldn't have to be, what is this? Oh, that's 3. Okay, that's fine. But what we would do is we'd sketch on here. We draw, did I get it? We draw out, I don't know, maybe to there. You just do this, and just make it 15 sounds fine. And then you just take this, and you extrude it by 5. And then now you have like, 5 is actually so big. Why did I even choose 5? Because now if we're doing this, we don't even need to countersink it. Dude, this is the problem with design, is that every time you try to do something, you add so much, you just increase the footprint. You just keep increasing the size of it until it's a monster and it takes 6 hours to print. But anyways, you do this, and then you do this. And you make, what's the distance between here and here? 15. Oh, wait. And this you make a, did we do threaded inserts here, or we just made a, I think we just made M4 hole 2. Oh yeah, we don't even have that. So just say it's 4.4. So then you take this, you extrude it, remove up to next. Then you do a circular pattern. Feature, this, axis, this. Okay, and now, oh, what do we do about that? We'll need to cut that out somehow. I mean, I really don't like that it's a rectangular cutout anyways. That's why it's nice that they have that. Wait, let's just try that. I'm going to do a new part studio. And it's just going to be, so we're just going to make that 100. I'm going to just make this. Oh wait, wall thickness of, yeah, that's fine. And we're just going to extrude, jeez. This, and let's just extrude it by, whatever, it doesn't matter, 50. Okay, and now, is this where we want to sketch on? Is this where we want to sketch on? So we want to use these 4 things. And then we want to draw a line. It's a construction line between this and this. Then we want to draw a circle. It's like out here. Is that the midpoint? And we want this to be, let's say 25. Wait, what's still... Okay, so can we get... We have tangency. Can I get a point? Yeah, Shift S. I want a point on the midpoint for no reason at all. So now this and this are H. Okay, now we're constrained. So now we can take this profile and we're just going to extrude it, remove through all. There's just absolutely no way that it looks like that. I mean, that looks so dumb. Or actually, you know what? Maybe it's fine. So what we're going to do is, in this sketch, we're actually going to make it +6, right? 31. Should we make it 31? Okay, and first off, I want to delete this point so that this is... Oh, wait. Why doesn't that work, dude? Blind. What? I don't really get what is going on here. Okay, so fuck it. We're gonna go here. I'm gonna delete this stupid tangency. I'm gonna say the distance from here to here is, yes, sure. Let's make it 5. How about now? Does that work? Okay, but what we also want to do, I'm gonna take this sketch and we want to make it one that's 25. So we got this. We have that extrude. Oh, that's silly. So what we want is... How do you make a pipe coming out of a cylinder like that? I think maybe you, yeah, how do you do that? So you have a cylinder with a hole in it, and you want a pipe to come out of it. How do you do that? You have a... Okay, well, let's start simpler. We just want to delete this and this. Okay, let's just start on a tangent plane, maybe. So, plane, tangent, click on this. Okay, now we make a sketch on there. This thing's lagging, bro. Okay. Okay, we're gonna make this. So this we're cutting out of the thing. So first off, let's make here to here like 5. Let's make this 30. And then we're just gonna extrude this, remove 5. Is that enough? Probably not. 10. But now we want to draw on this again. Wait, did I get the wrong face? Can we use this and get the center? Nice. So we're going to make this like that. This and this like that. And then we're going to extrude this in both ways. We're going to extrude this second end position. It's an add. This one is going to be up to next, which will fail, obviously. That's so annoying. Wait, which one is that one? Wait, I can't tell which is which. Oh, is that it? Did we do it? Okay. So maybe that's how we do it. And then we still want a brim below it. So we will need to make that base kind of thick, right? Because you need this base and then this base. And this base is the thin one. This is the thick one to hold up the helix and everything. I mean, honestly, you kind of do want... Bro, I don't get that. I don't get that at all. Why? I know there must be a reason, but I don't understand why it doesn't let me do that. Like... I mean, can we just do something goofy here? We take this. We delete whatever this tangency. Now we can move this up. We say the distance between here and here is like 0.001. And now the extrude works fine. But what is wrong with this? Oh, yeah. So wait, let's look at that sketch. That's a 3. So we're going to make this like 3.001. So then, whatever wall we have here, or whatever like base ground we have here, and then in here we actually want to... Do we want to thread this? I don't know how we're planning on doing this. ANSI standard? I don't know. Pitch of 2 millimeters. Wait, why didn't it do anything? Oh, you know why? Because it doesn't do outers. Yeah, it doesn't do outers. Or I mean, it doesn't do inners rather. I don't know why it doesn't do inners though. Kinda spooky. Okay, I'm almost ready to start this then. Well, that's weird. Is that because of the threads? Or is that because we do this? No, it's clearly the threads. That's no good, man. What do they call it? Are they just called inner threads? Yeah, internal. Wait, no way, dude. If you just make a basic hex nut, the thread tool doesn't do that? Oh, I don't like that. Wait, that's not what we want, right? Flats distance of 12. A circle 8. Yeah, 8 sounds good. Okay, we can extrude this by I don't know, 6. And then if I click this in threads. Oh, what? Why didn't it work for mine? I think. Yeah, I mean, it's just a bug, dude. It's just a bug. Because this works. Unfortunately, it's not really. Wasn't there one specifically for printing for printed parts? Oh, these, but PP. I wish it had more parameters. Oh, it's closed source. Is there an offset face? Could I just offset face them manually? So you select this face and you do offset surface. I can't tell if that's removing or adding material. No, but I don't think that actually, it's probably this. Wait, I don't think that, oh, that's right. Move face. Extend or trim. I think it might be this. All right, well let's try move boundary. It's gonna be 0.15. Oh, okay, that doesn't work. Move face. Select this face. Select this face. And we want this to be 0.15. It's impossible to tell. Wait. What the hell? I'm confused, honestly. Let's see. I don't want a plain offset. Okay, hold on. Is it move face? 0.115. See there, it worked. There it goes wrong. Too bad you can't offset face. I don't know what you do. You have to change the whole thread profile or something like. Long it's normal. Okay, so I gotta just get this thing printed. Okay, let's. Okay, so the first dimension is gonna be stepper width plus 1 millimeter. Wait, no, because right. Okay, so we did this, and then we did this, and then we did this. So this we can delete. So this is just barely cleared. What? Oh, I honestly find that whole user interface a little unintuitive. Okay, so that's what we have going on here. Now, we need this. We have this, which is going to be probably 1 plus, I don't know, it probably could be 3. And then from here, we have 25. Okay, so what is the dimension of this? This is 120. So this is smaller than what we had before. So what I'm doing is I'm just sort of recreating the, okay, and then what we have here is going to be, this is just going to be like, well, I guess it's going to be 5. And then from here, again, this is just going to be, yeah, 15 is probably good. And then, can we get the normal? So then we're going to have some holes here. And these are probably just going to be M4 holes. Yep, pretty much perfect. Okay, but then we need the pipe, which realistically will go like this. Yeah, that's about right. But for that's looking from the top. It's going to be a circle. And actually, and then right here, yeah, so we kind of want it to be like right here. And then we're going to have this helix start here, and it goes around, and it carries them down. And then there is a little bit of a, there's like a, thing here. The 2.5. Like that. Yeah. Sure. And then, wait, we probably have that somewhere. Yeah, this is defined as 25. But wait, no, we did this wrong. We need to fix this because we're missing a wall. Yeah, wait, how do we want this to go? So we have the motor, and then we have the housing for the motor. And then we want like a brim on the motor, because this isn't part of the real thing, but this is going to have holes in it. So that means that this base needs to be thick. Anyways, this to here, we could probably get away with 10. So then, do we still have these axes? Where did these planes go? So now we have this here. This is also going to be one of these M4 2s. And this distance here is going to be 5. And then this is going to be a circular pattern. And how is that going to work? It's going to stick up. Yeah, that's why I was saying go from under, because the helix. So maybe that is from under. Okay, so now you have the... So this whole thing is the... this whole part is just the... that's just the motor holder. Even that's going to be annoying to print. Damn. And then it's not going to be flush on the ground and everything. You'd have to countersink both, but I don't even know how you get it in there. This is tough. Maybe we could do something like they did with just slots. It slots in and then... Actually, wait, why don't we... Yeah, okay, wait, hold on. I have an idea. Wait, I don't know if it's going to work, actually. What I was thinking is, like, instead of fastening down, you fasten across. I'd make them low so that it's easy to install. They'd be short. The nut would probably be on the outside of the rim. But then what you'd have to do is that you'd have to increase the size of the housing. Okay, so let's do one more. So this is good. I actually like this sketch because it's a good cross section. I wish we could copy some of it, but whatever. I don't really mind the repetition. Okay, we're gonna do another sketch. Okay, so the first one is always the rectangle. You set these two equal to each other, and you dimension this to be stepper width. Okay. And you do this, and you say that the distance from here to here is 1. So there's already that. So that's already a change that's better. Now that is going to be the inner wall of the... Okay, I'm sort of done with that. This is going to be the outer wall. So this to here, let's just make this 3. And then there's going to be a short... We could honestly just have it be 2 tabs, but I don't really mind having it go all the way over. But then, so we're going to make a circle here that just has the clearance in it. This is just going to be 0.5. And then from here, we're going to make another circle, and this is going to be 3. We're doing wall thickness of 3 right now. Just how it goes. Just to see what's up. Okay, and then there's going to be holes that go through this. So let's just do that like this. Just say it's 5. Or it's okay, whatever. So there's a bolt that goes through, and there's a nut in here. And this thing only goes up like 10 high. Okay. And so then this thing comes down flush. We don't actually have to make it come down flush, though. It could sit on something. It could sit on some... Yeah, right. So decouple the fact that you have it slot in based on like a vertical constraint from the fact that you actually have to bolt it down vertically. So you're still bolting it down horizontally, but you have it slot in. So what I'm saying is, like, you either put the motor holder part on top or you slide it from the bottom. But either way, there's going to be some notch that prevents it, so that you know the holes are aligned. I kind of like that design.